we were talking about the chain rule. And today will be day one of our notes because I'm going to go over some, and mostly tomorrow, it's mostly going to be examples, how they can look differently, how to attack them, try to give you a little bit more steps when you see certain types of problem. But in the end, remember, nothing beats doing these problems more than practicing. There's a huge thing to say about just going in and doing problems and doing problems. Tonight, of course, I'm assigning Delta Math. Tomorrow will be the actual homework. Both have been released, though. So the whole focus on the chain rule is talking about composite functions. Now, of course, when we're talking about analytical functions, the only analytical type of function that we're working with right now are power functions. So, and that's still going to hold true for tonight. So the only thing that's going to be dealing with is power functions, but you might be dealing with functions in function notation. A composite function is a function, and I'm going to put a function is FTN, functions within a function. Function, I'll put that around it because you can have multiple functions within a function. You can have a function inside of a function that's inside of another function. All right. You can have two functions that are within one function. So you can do a lot of different things. Like I said, that's why we have to practice it. Typically in your Math 2 courses, your Math 3s, your advanced algebra pre-calculus courses, you dealt with the idea of, hey, okay, you get one function y equals g of x, and you have another function, or f of x, sorry, and another function y equals g of x, and you combine these to get a new function y equals f of g of x. Now, of course, because this is function notation, you're like, wait a minute, I have y, and I have y. So we just typically write this as a new function like we've seen on the tables, h of x equals f of g of x. So this is the type of function we're looking at. And of course, we could have said h of x equals g of f of x as well. Now, I didn't give you specifically what f of x was. I didn't give you specifically what g of x is. The idea is that there are some types of functions. And in today's work, of course, like I said, that if I give you the actual function analytical wise, it would be a power function. Now, in terms of just some review, if I asked you for h of 5, well, typically what you would do is first you would find g of 5, and then you would plug g of 5 into f and find f at that value. Okay. So the idea is that it's like you put a function, it's, you've had those images that you had some type of function machine, and you put in 5, and this is function g, out comes out g of 5, and this goes into another function of f, and out comes f of g of 5. So that's kind of like the visual representation of what goes on when we're talking about these compositional functions. I.e., if I told you that f of x was 3x squared plus 1, and g of x is 5x plus 2, and I said, okay, what is f of g of 5? Now, this is just a straight algebra question, okay? Now, there will be a calculus connection to it, but, that's why I kind of want to go review first. Now, there's two ways you can do this. You can go with the traditional route, the route I just showed you, and we find g of 5 first. G of 5 would be 5 times 5. Oh, this number's going to be big. Let's make that g of 1. Okay. The number's just going to be really big. I don't want it to be really, really, really big. So we'll go g of 1. plus 2, which gives me 7. So f of g of 1 is the same thing as f of 7, which would be 3 times 7 squared. Still a big number, but a little bit more manageable. Plus 1, that's 49 times 3. 27, 12, 147. So I get 148. Now that's one way to do the problem in terms of evaluating it. Another way that we could have done the same problem is we could have actually found f of g of x by actually putting in what it actually means. We put wherever we see an x for f, we replace it with g of x. So we call f, I call f the mommy function, and I call g the baby function. And so we're going to write what f is, and f is 3 baby squared plus 1 . And so when I see g of x, I'm going to replace it with 5x plus 2. And this right here is f of g of x. Now, there's some things that we can do with this function, okay? Now, I want to note that we could expand. It is not too difficult. So it's not too difficult to expand this. So, if I were to, I would get like 3 times 25x squared plus 20x plus 4, all that times 1, which gives me 75x squared plus 60x plus 13. And this is equivalent, okay? That is equivalent to this. Now, that's going to be important because we're going to be asked to take derivatives of functions like this. Now, while it would be nice, this is now this is a power function. And we could take the derivative of that power function, right? We would be like, oh, that's nice. I can take the derivative of that. So if I wanted to take the derivative of this function, I get like 150x plus 60. F of g of x prime would therefore be 150x plus 60. This is the calculus. And that's kind of like our goal today, because our goal is going to be to find the derivatives of these functions. We're more, in calculus, we want to talk about rate of change, the slope function, the tangent line. So our goal today will be able to find this derivative, but without the expansion method. All right? So a little review as we just gone over what a composite function is, how to evaluate one, based on just pure algebra, how to find that actual function, and if we want to manipulate it, how we manipulate it. Finally, we ended up with that problem part at the very end right here that I just wrote is, well, if I remember, because when you get a function, the whole question is, if we need to take the derivative, we need to, the way you take a derivative, this is so important. This is why I say homework is in calculus is, redundancy and doing problems is more important. So it's literally like if you're not doing calculus homework problems, there is no success. If you're not staying up with your homework, I'm sorry, there's no way to expressly be nice about it. You cannot be successful in AP calculus. It can't happen. No matter how brilliant you are, because there's so many different ways of problems that happen that you just need to practice. Even when I was taking this course, and I was the strongest when I took it, I had to do problems after problems after problems because you just need to get a feel for it. It's a new language. And as such, when you get a function, even if it's a composite function, the biggest thing is, all right, let me look at how this function looks. Based on how this function looks, based on what type of functions I'm dealing with, I will have to utilize different rules. Always in the back of my mind, can I rewrite this function in a different way? Can I use algebra to make this problem easier for me? To make this problem more efficient for me? Sometimes it can be helpful, but this is a problem where even at a problem, this function, I call it basic, expanding it can still lead to a lot of problems. Now, I'm very good at my binomial expansion because I've done that a lot, so I was able to expand it and then multiply and do that without making a mistake. But I can tell you that if I did this problem 10 times, or if I did this over the course of 10 years doing this exact problem without looking at notes, which I actually didn't even look at notes, I'll probably get it wrong once out of those every 10. And as a calculus student, even 1 out of 10 times being wrong, and I'm talking about your instructor here, your teacher being a calculus, not pro, but, much of an expert as we can get to, hopefully I am, I would get it wrong 1 out of every 10 times, which is a little too much. If I know the calculus rule that I'm going to teach you today, that won't be the case. All right, so let's do the calculus part. Let's do the main part of the notes. The chain rule. The chain rule says that, all right, if we want to take the derivative of f of g of x, and actually let me write it this way, kind of like how I wrote it before. I'm going to write it in a different color. G of x will be in green or purple. Then the derivative of this function is the derivative of the mommy function. The baby stays as is inside, and then hence the name chained by the derivative of the baby. So we literally take the derivative of the baby and multiply it on the outside. This is the chain rule. This is the rule that you'll be utilizing in basically every part of your homework today, tomorrow, and tell you the truth, it's likely to come up on the majority of the problems. At least over half of the calculus derivative problems that you're going to see will require some form of the chain rule. The chain rule can be made, you can make quick mistakes with the chain rule, and if you don't master the chain rule, you can really make a lot of mistakes on it, which of course we don't want to do. So we need to make sure you get that. Now, alternatively, I can say y equals f of g of x. And this is a method that can help many individuals break down a problem. We call the baby u. So u is g of x. So then we can say that y equals f of u. And if we want to find the derivative of y with respect to x, the derivative of y with respect to x would be the derivative of y with respect to u times the derivative of u with respect to x. So this is another version of the chain rule. It says that if I have a function as a function of u, and I want to find a derivative with respect to x, it's dy du times du dx. Well, what do I mean by that? Well, dy du is just the derivative of f with respect to u, and du dx is g prime of x. So what this tells me, I know it's very overwhelming, that's why we're spending the 2 days on it, is f prime of u times g prime of x, which is f prime of g of x times g prime of x. So they both lead to the same part, okay? They both lead to the same place. The chain rule is a very important rule of differentiation in calculus. Very, very important. Whenever you see a function within another function, you have to link it. But the main thing that you need to do is to keep the baby and then chain the baby's derivative. I will often say, don't forget the baby. And when I say don't forget the baby, I really mean two things. Don't forget to leave the baby inside, and don't forget to take the derivative and multiply by the derivative of the baby. There's two things that can go wrong with the baby. One is, the most common mistake people make is that they'll take the derivative of the baby inside and they'll just leave it inside. They won't multiply by the outside. All right, that's the biggest mistake I see individuals make. They'll think of it's f prime of g prime of x. Like that. That's the biggest mistake I see individuals make. They take the derivative of the outside and then they take the derivative of the inside. But that's it. They literally just leave the derivative of the inside. If you see it, if you see the baby in your function, you should see the baby in your derivative. That's the most important piece. Nothing beats it though better than practice. So I'll let people catch up on writing this and see if there's any specific or additional details of questions that you might have that I can elaborate on before I go into examples, which is the big piece of the chain rule practice, is practice. No questions? You guys good? Let's look at that example that we just did before. H of x equals 3 parentheses 5x plus 2 squared plus 1. Now, this is the same thing as f of x equals 3x squared plus 1, g of x equals 5x plus 2, and therefore f of g of x is what I'm looking at. So it's the same idea. Find h prime of x. And now we're going to use the chain rule. All right? The chain rule. You got to see this as a compositional function, the inside function, the baby function. So and I can't stress this enough. That is the baby. And the baby will be in the answer. We have to first be able to recognize that this is a composition, that this is a chain rule for problem. All right? So if you can't recognize this as a chain rule problem, then you're going to, as a composition, as a chain rule, however you want, as a function that has a baby, 3 different ways of wording the same thing, you're going to be in problems. So what you need to see is that the 5x plus 2, and you have to realize that the 5x plus 2 better be in my, it's like a check thing. Like if I don't see 5x plus 2 in my answer, I know I've done something wrong. All right? If for some reason, of course, unless I expand the answer, but when I find a derivative, it better be there. So let's follow the rules. So h prime of x, that means, okay, it's a power function. So I'm just gonna block out that baby at first, all right? So I'm not gonna even think about it being there. So don't even see it. Don't even think of it. You don't even see this right here, right now. So I'm thinking about that 3x squared plus 2, or the 3 something squared plus 2, 1, plus 1, sorry, not 2. What's the derivative? How do I take the derivative of 3x squared plus 1? What would I do? Somebody.
Bring down the 2.
Bring down the 2, subtract by 1, and that's it, right? That's what I would do. And that's what we're going to do here. All we're going to do is bring down the 2 in front. I'm going to leave the baby and then subtract the power by 1. So the derivative of this is 3. I leave the baby times the power of 1. That's 1. That's a 1. I leave the baby inside. And then I chain times the derivative of 5x plus 2. And what is the derivative of 5x plus 2?
5
times 5. And then I add the derivative of 0. I mean, they add derivative of 1. And the derivative of 1 is?
Nothing. 0.
Yeah, 0. This is my answer, yes.
So we don't change the 3 part? So we don't multiply the 3 by
Oh, that was me. That was an error on my part. Thank you. 6. Thank you. 5x plus 2. I was so focused on this part right here. The 5x plus 2 is still in my answer. Of course, you're not going to see the answer written like that. This is now, if I clean this up, this is 30 parentheses 5x plus 2. Which is 150x plus 60. If you remember, if you can recall, this is what we found earlier. When we expanded it. Okay. When we use the power rule in applying the chain rule, we call this and it's not a big surprise, the power chain rule. So the only chain rule that you'll be utilizing, the only version of the chain rule that you'll be using tonight and tomorrow is the power chain rule. In other words, what this means in layman terms, or in other terms, not layman terms, because it's still kind of complicated, is that the mommy function is a power function. So if I was to break this up as two separate functions, f of x and g of x, that f, if it's f of g of x, the f would be a power function, like that 3x squared. And so all the problems you're going to see today, and in reality, in the problems you're going to see today, the mommy and the baby will be power functions. But the power chain rule is the only rule that you're using today. And so the power chain rule says the following. And you technically don't even have to memorize the power chain rule because it's just the chain rule. The power chain rule is that the derivative of some function to the nth power, some baby, is n times u to the n minus 1 times du dx. Basically, this is the rule that you're going to be utilizing over and over and over in your homework. All the functions will be some version of u to the n. They might be a constant times u to the n, like that 3 was in front. But it's all the problems tonight are going to be, and the most important thing is you need to master how to do these types of functions first, all right? If I tell you what rule to use, if I only give you one rule to use and I say you're using this rule, here's the rule, all the problems apply to this rule, then you best know that you have to be able to master and be able to do all of those problems before you can move on. If you move on to Thursday's lesson without having been able to do all of these chain rule problems that I'm going to be giving you, are the majority in terms of their basic forms. So I'm going to give you some more complicated ones when we apply the product rule and the quotient rule. But if you are unable to do these problems, you're going to run into a lot more problems. You're going to continue having the same problems throughout the rest of the material. Let's do another example. F of x is equal to the square root of x squared minus 5x. Find f prime of x. Okay. So, what do we do? How do I attack this?
Maybe try to put in simple calculus friendly.
Calculus friendly, good. I'm rewriting the function f of x. I'm not taking a derivative yet, so let's do some algebra. What would that look like?
Would it just, instead of the x squared, would it be just x or something?
That'd be bad algebra.
Or
Anybody else? Or Ariana, can you fix it? Or somebody else want to chime in? That's a very common mistake, Ariana, that you said right there. That is a very common thing that students will do. And so it is very, very common, and it is very, very wrong, and it's something that we will definitely want to make sure we don't do. So we're not gonna do any like expanding or cancelizations. We're just rewriting it.
I don't know.
Okay. Somebody else? We're not doing any calculus here.
Just keep it the same then or something?
Yeah, but we are going to keep it the same. So, but how are you going to rewrite it? Same time. It's a square root problem. So how did you do? Everybody here has been doing square root problems all over the homeworks. So how do we do square root problems?
Would it be x squared parentheses to the power of 1/2? I don't know.
Close, close, close. Very, very, very close. You forgot something. That was it. Come on, there's other students in the class. I hope. I mean, we need to. This is one of the reasons why I have to basically keep the lesson in terms of so many times where I just have to do examples and notes. Is you're not speaking up the rest of the class, so I have to keep going like this. And I hear some people being like, we need to do more like stuff like the breakout rooms, but then if I can't get you to talk, if I can't get you to do work and problems and learn and believe that you can do this type of notes and problems on your own at home, I have to apply it like this. I don't like to, but I have to. All we got to do is rewrite this to the 1/2 power. All square root is raising the whatever's inside the square root to the 1/2 power. It's the same rule. When we saw problems that was y equals the square root of x, you said, oh, that's the same thing as y equals x to the 1/2. Nothing different. Nothing different. And that's not calculus. That's why I always got to kind of try to always put that out. It's not the calculus right there. Because once you get it here, then you're just applying a simple rule. Bring the number down, keep the baby inside, subtract by 1. It's an algorithmic rule. When I say simple, I mean it's algorithmic, meaning that you follow the same steps. Bring the power to the front, keep the baby, subtract by 1, multiply, chain to the derivative of the baby. So, f prime of x equals what? I literally told you what to do. Well, we'll just wait then. What do I do?
Do you have to move the 1/2 in the front of the x squared?
In front of the parentheses, not the x squared.
Yeah, in front of the parentheses. And then would you what would you keep the inside the same or something?
Yep.
Or would you have to change it? Oh, okay.
Keep the baby the same. That's the hardest mistake. That's the biggest mistake that most individuals make in the calculus.
Okay, and then you gotta times it by
No, not yet.
2.
Not yet.
Oh, you gotta do 1/2 minus the 1.
So negative 1/2. And then times.
And then, yeah. And then you gotta do 2x minus 5.
Correct. Can anybody tell me why the way I've written it is wrong?
Oh, it's wrong?
The way I've written it right now so far is wrong. See, nobody else wanted to chime in at all to any of this. It's going to be very, very... This is a topic that is, as algorithmic as we can get it, which means it's all about participating and practicing. And right now, it's only been Ariana. I need others. I need others. I don't see anything in the chats, the private chats. Like, to tell you the truth, I don't even know if anybody else is in here. 2x minus 5. It's times the, and that's that parentheses, because the 2x minus 5 needs to be attached to what we took the derivative of. And that's the answer. Of course, I might need to rewrite the answer and do some cleaning up. Like if I needed to look, I look at a multiple choice problem and I don't see this, I would see this as being the same thing as 2x minus 5 over the square root over 2 times the square root of x squared minus 5. This is how you would probably see it on a multiple choice. So that's how it would show up on a multiple choice. Okay. Now remember, you can private chat to me and put in your comments so that I can see that you're actually here as well for these. All right. Next example. F of x equals 3 over 2x minus 7. Find f prime of 2 using the power chain rule. Now this is a problem, and I say this right here. I say using the power chain rule because this could use what rule? What other rule could you have done this before? I could have given you this problem yesterday. What could you use to do this problem? You could avoid using a chain rule and use what rule? You can type it in the chat. What is it? The quotient rule. Yeah, you could have just used the quotient rule. And in reality, both of them are probably. I actually think that the chain rule is an easier version of doing this problem rather than the quotient rule. Now, the reason why the chain rule is a more efficient, better way than the quotient rule in this problem is because you don't have a function of x on top and a function of x in the bottom. Whenever you don't have a function of x on both the top and bottom, while you can still use, I mean, I guess 3 is a function of x, but we don't have an x term in both the numerator and denominator, the quotient rule is typically not the most efficient way. There's other ways that you can use algebra. And in that case, what I can do is I can rewrite this f of x as 3 parentheses 2x minus 7 to the power of what? You can like again, you can type it into the chat. You can private chat me. Let me know you're out there. This is the same thing as 3 times 2x minus 7 to the power of
-1.
-1. Some basic algebra right there. Now, I said to find f prime of 2, but to find f prime of 2, I first need to find f prime of x. Then I can find f prime of 2. All right, so f prime of x is what? Been pulling teeth from you today. Power chain rule is the only rule. You're doing the exact same thing. There's almost no difference from what you're doing right here versus the previous example versus the example before that. You have it exactly in the form that you would want to take the derivative. It is perfectly ready to take the derivative using the power chain rule. It is an algorithmic step. You do this, you do this, you do this. So -3 parentheses 2x minus 7. That's a start, and that so far is correct, but if you left it like that, it'd be wrong. To the power of -2, very good. You added that, and now you're on track, but you still have the wrong answer, and you would get no credit on APA Calculus. Let's finish it. Let's finish it. It's almost there. If you wrote it like this, you'd be like, oh.
Okay.
What is it?
Times with the brackets 2.
Times 2. And you would get full credit for that. Now, that is the derivative. If I just asked you for the derivative and you typed that in, you wrote that in, I'd give you full credit. If I only asked you for f prime of x. This is the same thing as negative 6 over parentheses 2x minus 7 squared. That's algebra. To rewrite it, because I want to find f prime of 2. So it's easier to do f prime of 2 once I've written it a lot easier, because raising a power to the negative second power is a lot of mistakes get made. So f prime of 2 would be negative 6 over parentheses 2 times 2 minus 7 squared, which is negative 6 over, what is that, 4 minus 7, so that's negative 3 squared, which is negative 6 over 9, which is negative 2/3, which is what you would see on your multiple choice. Now, if we had tangent line problems, which you'll see in your homework tonight, if I had a tangent line problem, then I want to know that in the previous example, my answer would be y minus f of 2 equals negative 2/3 times x minus 2, because that's f prime of 2 right there. I could find, if I had asked for a tangent line, and of course f of 2 would just be 3 over 2x minus 7 times 2, sorry. Which would be 3 over negative 3, which would be negative 1, which means I get y plus 1 equals negative 2/3 times x minus 2. My point for this last part is that if I had asked you instead for, I can ask you for the derivative at a point. I can ask you for the derivative. I can ask you for the slope at the point, which is the same thing as the derivative at a point, f prime of 2. Or I can ask you for the tangent line at a point, such as x equals 2. So find a tangent line at 2. So these are all questions I can keep asking you over and over and over, and they make problems that start off relatively one concept and expand to more. Product and quotient with a chain. Okay, so there are some problems in your homework tonight, and I do want you to practice these ones, okay? You might get a problem, and they're not overly too bad, but if I give you a problem like y equals f of x times x squared plus 3 to the 5th power, and we wanted to find dy dx, this is a problem that you have to recognize as a product rule at first. So when you see this problem, you have to recognize that this is a product. This entire part right here is my u. This entire part right here is my v. So when you see a problem like this, you have to go off in your head and say, oh, this is a product rule, first and foremost. All right, if that's the product rule, then I have to find what is u prime. So what's u prime in this problem? If u is f of x, what is u prime? It's obvious. I'm not trying to go crazy here. If u is f of x, what is u prime?
f prime of x.
F prime of x. And what is v prime? Oh, okay, that's just what we just learned. Once again, same problem over and over and over and over and over. So what's v prime? You bring the 5 in front. You keep the baby inside. You subtract the power by 1. You multiply by the derivative of the baby. Chain rule. So in order to find...
How would you know if it is the baby? How would you know if it was the baby?
Because it's trapped inside. It's trapped inside. It's being raised to the power of 5. So it's that x squared minus 3 is part of another function. Okay? And now to find dy dx, you just piece it together. So dy dx, remember, is u prime v plus v prime u. So dy dx would be f prime of x times x squared minus 3 to the 5th power plus 5x squared minus 3 to the 4th power times 2x times f of x. All you're doing is replacing u prime, v prime, u's, and v's with what you found them to be, and now you have your derivative. And if I asked you to evaluate this find this at x equals 1, then you would just replace, you plug in x equals 1 for all of the x's to evaluate it. So there is a challenge in your homework on the Delta Math. The third set of problems deals with problems like this one right here. Okay, the third set of problems. If you don't get it done, I'm not going to be a big stickler on it, but I can tell you that if you really want to push to get these ones being understood, because tomorrow's lesson is basically what I'm going to be doing tomorrow. So what I did right here, I'm going to really elaborate on these types of problems tomorrow. However, I'm going to keep it in that Delta Math still, because I'm not assigning Delta Math as tomorrow's homework. Tomorrow's homework will just be a problem with an actual homework handout problem that you're going to practice with. It's 9:05. That's their class time. I'm available at office hours. There's tutoring available. I think there is a tutoring session today for those who are always signing up and attending. Take care. I'll see you tomorrow.